Yeah, so this, as you all would know, is a series of 3 talks. The talk today will be on classical black holes.
This is 50 years since Hawking's famous paper, which discovered the black hole information paradox. And that paradox has driven the most interesting ideas in theoretical physics for a long time. And so it looked like a good time to sit down and take stock of what people think we have learned by attacking the paradox. And what is interesting is that even 50 years down, people don't agree on how to resolve the puzzle, but they have done a lot of work on it. So we just wanted to bring together people who have looked at the puzzle from different angles and to share their thoughts and see how they differ from each other. That's the goal.
Where it pitches, and then past this. Right.
I always had this idea that ADS3 with some matter outside basically is much nicer than ADS4. ADS4 is much more.
Your phases of EDS supergravity, which is, I think, sufficiently obscured, it's completely unclear what I'm talking about. So I will start with a more generic kind of introduction. The question that you might ask in such a setting is, what are the ground states?
That doesn't cost anything, and you can do the same analysis there. So that means there's nothing special about that.
But that's why I was saying that I think things are different from global ADS and for the Ramon vacuum.
Study of antimatter space illuminated greatly the puzzle of black holes.
It's a story really of a great game of ideas, great games of advancement, is the great game really of the 20th century. They stimulate people to go even on a shorter scale and then study really nature to the tiniest possible distances and try really to understand what is the fundamental forces of nature. And people also turn the gaze to the sky and start to understand for the first time our stars are growing and our star is dying, as a matter of fact.
Where are we now and what's the future?
Look, the answer is I don't really know. When you're in the middle of something, it's hard to get an outside perspective.
I could shoot in various directions.
Yeah, that's
So
right.
how do I choose where to shoot, and if I shoot them all, what do I get?
Function. So how is that different? Analytically continuing, how is that different from guessing that that function is analytical?
Yeah, so the problem is that the CFT correlator has singularities.
They will always collide.
They will always collide.
Some of them on the body will collide.
There is a very subtle point here about this work by Alex May.
And then I can look at the top and bottom tip of the diamond. So there's no actual operator there in the CFT.
Sure, the wave function has some support on some stringy mess, but it also has a nice description in the region I like, where all of the solutions are valid. I just extend them, continue them on to other parts of the configuration space.
There cannot be anything very complicated, very big in the black hole question, because I could start making a black hole of 100 blank masses or 50 blank masses or 20 blank masses.
Very nice low energy fields, actually. There could be other stuff
Yeah.
too, and that means some of these fields have to be declared illegal.
So when Pierre arrived, I was interested in microstraight geometries that could be relevant for real-world physics. They provide you with concrete examples of things that look like black holes that are not black holes, for which you can analyze the problem of which aspects of observables in the sky tells you you're seeing black holes versus other things.
To the world that I live in, but when I do the projection at a later time, it's a highly entangled thing, right?
Well, I'm just trying to understand the sort of evolution on the level of Hilbert spaces you're talking about.
Yeah, and it's the superposition of all of those things, which is the actual quantum field theory evolution.
And you could ask the question, what new things in string theory happen when a collection of brains that you might call a brain star gets dense enough that it starts to form a black hole? So I've been looking at what are called 5-brain stars, not quite black holes yet, but they're starting to manifest the stringy ingredients which would explain the structure of black holes.
What is the new effect which tells me that if I use box phi equals 0 to study the problem the way Hawking did, I am doing something wrong?
So what do we do in canonical quantum gravity? We have maybe some operator and we evaluate it in the state. This gives us quantum field theory in a fixed background.
I'm a PhD student in physics in Simon Center. There are lots of problems that I'm broadly interested in. In general, I think it's safe to say that I'm interested in theoretical physics. Sasha Zamolodchikov had proposed some conjectural Largen solution back in 2003-2004. spherical brain models, and we just proved that his conjecture is actually correct in at least a large n limit up to the subleading large n.
Do you think there is a connection between physics and music?
There's an element of abstraction that I think both of them have, but for me at least they don't serve a similar purpose. They're different parts of me.
Now keep in mind that we're doing ensemble averages, which means that there might be special cases which will look a little different. De Sitter space has not been widely studied, quantum mechanical de Sitter space. And the world that we live in, the universe that we live in, appears to be much more like de Sitter space than anti-de Sitter space. So we have to study it. I mean, there's no real alternative. To the minus JP, this over P, this, we're doing it now in string units. So we could ask, what is the change in entropy if we change in energy, if we change the entropy by 1 bit? That's tiny.
You mean the
Well, look, what is a black hole emitting the photon? It's a Hawking photon.
Yes.
The Hawking photon has a wavelength comparable to the radius of the black hole.
Yes.
I love physics. I have fun doing it, and so I just keep doing it.
It's a curiosity that's the main driver.
I think so. Yeah, very much so. Yes, I think it's the curiosity and the fun of it. It's hard, it's difficult, it can be frustrating, but it's also tremendous fun when you get an idea to start exploring it.